the architecture and stuff. But before that, I would like to give you an introduction about DevLabs. We are a training coordinating where we put technical courses as training. We have webinars, we have classroom trainings, and online classes also available. The technical courses are written on the left side, if you can see the page over here. So the DevOps and tools like Docker, Git, Splunk are some of the parts where we have taken a lot of classroom trainings. Big data, Hadoop, and data analytics or data science is one of the leading technologies in the world. I am a certified trainer in Big Data, Hadoop by Cloudera, and data science as well. So that is my part on this one. Then we have artificial intelligence, another advanced level of big data, machine learning, and deep learning, which is the demand in the market right now. Then you have IoT, which is the Internet of Things, blockchain, agile, testing automation. Trainings are also available, and customized courses as per the individual or the corporate needs is also there. So these are some of the technical courses. If you guys are interested in any of them, you can visit the website. Okay, you are not able to join the audio. Okay, if you guys are not able to join the audio, you can bring it up. I'll check for Sanjeev. I'll check it for you why you're not able to. Just go, there's a join audio option available on the left side whenever you start it off. All right. Any other technical issues if you guys are facing, if you're not seeing the PPTs or slides, you just let me know. And Sanjeev, if your audio is connected now, so it's just being a yes or no, and then we can proceed ahead. All right. Next thing about the upcoming courses we have. Okay for you. All right. Next thing which we have are the upcoming courses on the right hand side, which you see, which are the webinars, boot camps, and certification programs in the near run. We have the calendar shared over here. The other calendars you can also check in the DevLabsAlliance.com website. You can check over there, and then you can also, if you have some customization course according to you, then you can proceed with that. So the Kafka, they have given, like we've given it as the classroom trainings or webinars with these asterisk marks refers to the classroom trainings. Generally, these trainings will be held on weekends so that anyone who is working also can join these trainings for 6 to 7 hours or 8 hours accordingly. 2-day sessions, 2-day classroom trainings. The session or the webinar which we are having right now for the Kafka one, if you want to go into a detailed course of that where we will be learning the high level end of Kafka, we will be having this classroom coming month in 14th of October in Gurgaon. That's a Saturday and Sunday. If you guys are interested after this webinar, you can provide your details to devlabsalliance.com. Check over there, register yourself for these trainings. A humble request to everybody to please mute your mics. A lot of disturbance happens around. Thank you. All right, so that was about it. We'll start off with our webinar sessions about Kafka. Here I'm considering, since there are a lot of people who have joined in up, so I am considering everybody to a knife in here as a fresher, as somebody who is just stepped up and wants to learn about Kafka. I know many will be professional over here who are already working on Kafka, but we have to keep in consideration everyone. So all right, so I will be so this is basically Cloudera's material which I have got it up here. is unofficial. So what we'll talk about Kafka a bit. Though I generally take it as an interactive session that you tell me about what you know about Kafka and when it was released. But since it's my turn to say all these things, so I'll be telling you about why Kafka was there, why it was developed, and why is there a demand for that in the industry nowadays. So talking about Kafka, what is Apache Kafka? This is basically, if you can see the screen, you will be seeing that we will be trying to cover these topics for today. What is Apache Kafka, the overview, the architecture of it, how you can scale that, what was the need to build Kafka, the cluster architecture, some of the command line tools, that is the exercise part. We will take 15 minutes at the end, like before we go to the question answers round. So around 4:35 or 4:40 we'll start off with the practical session of it. It's very basic, just to have an understanding of it. Also, I would say again that this webinar is considering in mind that anyone who has an experience, also who is completely a fresher into Kafka, who wants to learn more about this, is for them. And for high-end level, how to actually go through it, the classes, the schedule is already available on the website. You can check for that and you can go ahead with that. All right. First questions first, what is Apache Kafka and why was there a need for it? So I'll be using the certain terms over here. Let me, all right. Okay. We have multiple types of data. So say, okay, first of all, what we talk about the word big data, we are already talking about this. We know it's a huge volume, velocity, variety, speed with which my data is being generating, and so on. So that is what we call it as big data. When your traditional systems fall short of storing, data which is coming in the normal textual, in the columnar format, and something which is unstructured and so completely where your monolithic computing falls short of it, to save that kind of data, that data is a big data. So big data is basically a problem which we have to save, which we have to handle, because we have to do analysis on it, we have to perform some processing on it, and we have to make certain decisions after this. So we have multiple tools. We have tools like Hadoop. We have tools like Teradata is one of, SAP is there, which is working on it. SAP HANA is one of the another tools which we have. So there are certain tools which are available in the market which are handling the big data part. Hadoop being one of the finest one. The reason is because it is an open source, and it is license free because of the same reason, open source, and you have cheap commodity hardware. You do not make use of high-end servers and so on. So cheap commodity hardware, you can make use of your own systems and you can work with the clusters of it. Now, considering this part, we are saving all these different types of data onto the Hadoop net systems. There was in the Hadoop ecosystem. Now, what is an ecosystem? Is like multiple tools doing the different aspects of the things. Hadoop itself had a tools that was, so when we divide the data, we have types of data which is coming in a structured, unstructured, semi-structured, and so on. And then you have semi-structured. Now, the data which we are getting could be also in, of course, they are in these formats, but they could also be something which is static and which is dynamic. Now, when I say dynamic, static, it means, of course, I have a data which is already stored for past, like let's say I have contained it in a file system, or I have contained it in some in databases or something like that. That data is something which is stagnant, something which I have kept already, and I can perform some analysis on top of it. Let's say if I want to find out in the past 5 years, how have my sales been doing? So I have a data for the past 5 years kept in a database, and I can check for that. That's something which is static. Dynamic data is something which it keeps on, it's being processed every day, or produced, sorry, not processed, produced every single minute, every single second. Like, for example, if I want to check in my organization how many people are using social networking sites during office hours. So what I will do is, because since all the machines will be connected on the same LAN, in an organization, so I can check for the IP addresses of all these systems. Let's say you are using the organization systems, and then I can check what they are doing, every single minute, every single second. So the pings which you get every time, okay, they are hitting this particular website, they are hitting this particular website at this particular time, and so on, you can get the data. So this hitting of that particular website is happening every single second. It's being stored, it is being produced every single minute, every single second. That kind of a data which is not stagnant, that kind of data which is completely being produced by time references, that kind of data is called as dynamic, or we call it as streaming data, sometimes also called as event data. Now, event data, streaming data, it's something like you get, like if you search for tweets, you will be getting multiple tweets, and you will be storing, because there are millions of people who will be tweeting, and you will be storing these tweets and so on. But to perform certain analysis, you need to have the data to be stored at one point, because you cannot do analysis on something which is keep on, like it's streaming. You cannot do analysis, so you have to make it as a bundle. So you have to make it as you can say in a layman language, to stop at one of the point, make it a group of the posts or the tweets on which you want to analyze, and only then you can perform some analysis on it. So streaming data, we have been fiddling with this in this big data world. Structured data, semi-structured, stagnant data is something which you can work with fine. You have traditional systems, you have HDFS, that is the Hadoop file system structures. But something which is event-driven, that was one of the major forte why there was a requirement of streaming data tools. Now, somebody who has come from the background of streaming data, who's already worked on it, they might know that there were certain tools, like if I talk about Logstash. Logstash is one of the tool by Elasticsearch, where it was already working on streaming data, and these guys were working very fine. They specifically made this Logstash for streaming of the data. Then came Hadoop. When Hadoop came up in the industries, and since it was open source, so anybody could contribute to it. So Hadoop is still being used, like for accumulating data from databases. For that you use Scoop. For getting data as a streaming data, you use another tool called as Flume. Now, Flume was a tool that was that was specifically built up for completing the Hadoop ecosystem. So it was built to fill up the Hadoop ecosystem, but there were certain limitations with Flume. The reason was because you can run multiple Flume agents. If somebody has worked with Flume, they might know the differences. But it was you can say considered to be a very baby as considered to Logstash, which was doing, because it was doing very high-end level of it. You cannot do customizations completely efficiently enough in Flume as compared to the other tools which were available at that point of time. Flume was made just to fill in the gap of the Hadoop ecosystem, which was lacking because there was no specific tool for streaming data. And so they built up it. But then there was these guys working on LinkedIn. Amazing people. They made a new tool, and they made this tool called as Kafka. Kafka was specifically made for streaming of data, but the major agenda which they meant for that is SMS, that is subscriber messaging systems. And it is somewhat similar to if somebody has worked with RabbitMQ. So I don't know much about RabbitMQ, but yes, a bit about it, just because to understand how Kafka was also working. RabbitMQ, so this was basically a tool developed by LinkedIn for streaming of the data. It worked like a subscriber messaging systems. We'll take an example of it in the later run, and I'll explain you how it works. So this was built up, and now people who are working on Hadoop, because Kafka, which it was using, it was almost using the same architecture of what Hadoop was using. That is the master-slave architecture. So let's say an analogy, I being the master and you guys have to work according to what I say. So you guys are operating on or understanding my command, and you're giving me answers personally. You're not interacting with each other because this is the command which I gave you as a master. This was the same architecture which Hadoop, and somewhere Kafka was also making use of it to store the data and so on. So considering the fact that Kafka came up in the Hadoop ecosystem later on, people also started to work with both of them. So in the both of them, in the sense, I'll talk about these two guys, Flume and Kafka. So it acted as an added advantage because reason was that the added advantage over here, the reason was because of the certain properties of Flume and certain properties of Kafka. It became very easy. It became very, you can say, optimized solutions to run your streaming data, because there are certain, okay, for example, I gave you, so this was one of the customer they were dealing with. It was RBS in Scotland. These guys were dealing with that they wanted to get the data from Amazon, and the data that they were getting was in Avro format. So Flume is very compatible with Avro when you are ingesting the data. But since this data needed to be stored at one of the point and for a longer period of time, so they had to take Kafka also in between. So a combination of both of them worked very well with this, because there are certain pros, and you can say for Flume, and certain pros for Kafka. A combination of it works best. Also, if somebody has worked with Spark streaming, if somebody from Hadoop background, they might also know about Spark streaming. What is Spark? Sorry. Yeah, Spark. Streaming, yes. So Spark streaming is another tool by Spark where the core level is of the same thing, streaming of the data and storing it onto one of the, maybe on the HDFS or wherever you want to store the data. Combination of Kafka plus Spark streaming is also one of the beneficial uses of it, because Spark streaming, what it gives the benefit over there is that before even putting the data onto the storage area, you can process it before putting it up. So whereas Kafka and Flume is you're just pulling the data from one end and putting it onto the destination part of it. Whereas Spark streaming is something where before you put it on the destination, you are doing some processing using Spark. A combination of Spark streaming and Kafka is also widely used in the industry. So yes, all these tools are not individually people are making use of it, but yes, combinations works the best. Now we will talk about what. So we talked about what is Apache Kafka. It's usually widely used for data ingestion, somewhat similar to publish subscribe messaging system. It offers scalability, performance, reliability, and flexibility as well. Okay. Originally created at LinkedIn, now it's an open source Apache project. It was donated to Apache Software Foundation in 2011, and Cloudera is now making use of it in CDH 2015. So these are some of the characteristics of Kafka. It is scalable. It's a distributed system that supports multiple nodes. Now, before we go on to this particular website, to this particular site, this page, as is here, there are certain terms which I want you guys to be aware of. All right. If I'm going too fast with this, also you can please put it in the message box. Reason being because I know the time is very less. It's like 1 hour and we have to do a lot of architecture and project and run the queries as well. So that is why. Okay, so these are certain terms which I would like you guys to be very clear on. Cluster, and then we have daemons. Pace is fine. All right. Nodes, cluster, and daemons. So first of all, we talk about nodes. A single machine is called as a node. The laptop which you're working on, or the system which you're working on, it's a single machine that is called as a node. What is a cluster? Collection of all these nodes is called as a cluster. Collection of nodes. But now what is daemon? These are basically services which are running in the background. Services which are running in the background of every individual node. So keeping in mind, like say the Zoom service which we are connected on the webinar for, maybe there's another service of Microsoft which is running in the background. So these are multiple services which are running in one of the system. Now, considering this part, we have types of clusters. So just give me a second. All right, here. Yeah, so we have been divided with two parts of clusters. The first one represents a pseudonode. Pseudonode means that we have only one machine and all the daemons are working in that single machine. The second one being fully distributed, which you use in the industry. This means that the services fully distributed cluster. Now, this means that in fully distributed, every single machine or every single node will be having only one service, one specific dedicated service or daemon. In the industry, of course, we use fully distributed one. Currently, we are maybe using pseudonode cluster. Pseudonode cluster is where one machine, you have all the master and the slave daemons working in here. So the demo which I'll be showing is on the pseudonode. The same demo you can work on a fully distributed cluster as well. But since we are working, like just to give a demo introduction over there, we'll be making use of pseudonodes. If you guys want to practice Kafka clusters, basically I have got it onto the Hadoop cluster because I was making use of the same HDFS part of it. You can get it on some of the vendors which provide like Cloudera has already been built in one, and the software is available freely on the Cloudera site. Hortonworks one also gives you a Kafka already installed in their Hadoop ecosystem, and Mapper, I'm not sure of it, but whether it gives you freely available or not, but the above two ones give you Cloudera or Hortonworks. I'll just write it over here. And this is where your compatibility is with Hadoop. If you want to install individually, just go over to, just give me a second. Just go over to Apache's site, Apache Kafka, and download. You can go to the Apache Kafka site, download for that. These are the latest release. You need Scala also for downloading it because it works on, these are the binary downloads. Yep, so here are certain download releases, I mean the latest releases of Kafka, and you can check for that if you want to make use of it. Okay, coming back to the part where we left. Yep, services, pseudonode and fully distributed clusters, which we have talked about. So these are the daemons, clusters, and nodes. So these are certain terminologies which you guys should be aware of. Not only in Kafka, whenever you're working in distributed systems. So these are certain terminologies which one should be very clear of. Okay, coming back to the part of scalable, Kafka is a distributed system. So distributed means that you can scale up your system with multiple nodes, multiple machines altogether. Fault tolerant, it is persisted to disk, in the sense whatever data you're trying to save, it is persisted to disk and can be replicated throughout the cluster. Basically, If somebody is coming from Hadoop background, they will relate much to it, because I said the first thing, the architecture is somewhat similar, which we will do in the next part of it. High throughput, each system or broker in this particular case can process hundreds of thousands of messages per second. Low latency, it is flexible, and so on. Skipping up the part of theoretical, we will go directly onto the architecture of it. All right. So basically, Kafka works in this way. If I give you a very simple example in the day-to-day life, see, we guys, let's say, go to Domino's or Pizza Hut or Shopper Stop or any of these shopping areas or eateries. The first thing which they ask you nowadays is to give your phone number. Now, you give your phone number, and the next time, or maybe later on, after you've given the phone numbers, you start getting messages about the discounts available, about the, what sale is going on, and so on. Since you guys have registered your number with their server, that is why you're getting these messages. So what is this? They are making use of Kafka. This is one of the use of Kafka. So in this case, what I want to say over here is that we guys, not we guys, as in the people who are like the Domino's and the other guys, who register your number, these are called as the producers. So they are basically producers. So P1, let's say it's Domino's. There's another producer which is there, let's say is Pizza Hut. And the third one is also there, which is P3. Now they are not directly connecting to you guys. They are putting up their messages, one of the messages. Now, first of all, what is a message? We'll discuss this term also in technical areas, but just as a layman architecture, I'm telling you over here. So they produce certain messages. Whatever the message they are producing, it's being saved onto one of the systems, or maybe on the HDFS or somewhere on the disk. I'm saying somewhere as of in double quotes, but on the disk where they are saving that data. Fine, the data has been produced, it is being saved. Now, since we, as in we who give the numbers over there, we are basically consumers. Consumers who are consuming these particular messages. So if P1 is producing a message and the topic, under the topic called as Domino's, and one of the consumer over here who has registered themselves to that particular topic will be receiving that message. Also could be that this particular person, that this particular consumer has also linked in to the second producer. Maybe he has also gone with Pizza Hut. He has numbers registered on both these servers. So he will be getting the messages from both the producers. The reason what I'm trying to say here is that they are not getting the messages. Let's say there's another P3 also is doing. Yeah. So from multiple producers, they are getting the messages because they are not interacting with each other. Like directly, they are not contacting. Producer is producing a message, keeping it on the servers. The consumers who are associated, who are connected to the particular topics where the messages are being saved, they are consuming that messages. This one liberty of having multiple producers and multiple consumers was not there in Flume. And since it was not there in Flume, that is why many people leaned forward for producer-consumer services, for Kafka, because of this reason. So now certain terminologies over here as well. So first of all, what is a producer? Producer is somebody, producer, is one who produces these messages, and consumers are the ones who will consume these messages. Now, another term to be talked about, what are messages? So let me write over here. Any, let's say streaming data, any data which is coming as one line over here, which we call it as, I'm giving a phrase over here, there's just one line of that data becomes as a message, or we call it as event. Any event or stream of one data at one particular second, that becomes a message, and it gets saved under a specific topic. So another term to be referred to is what is a topic. Topic is certain where you are producing these messages. So let's say the producer one is producing a message and the topic name is Dominoes. So the Dominoes becomes the topic, and all the messages that are being produced under that topic, that topic will be under the topic called Dominoes, and the consumer who is linked to that particular topic called Dominoes will be getting all the messages. Now, why I'm saying that there could be one topic and multiple producers producing data to the same topic. Let's say, for example, you are registered to the Dominoes, which is in Delhi server. But let's say that number gets rotated to all the servers, be it in any of the Delhi outlets of, be it Rajouri, be it in the West Delhi, be it on the South Delhi part, or any of these. Now you start getting messages of anywhere where you are registered to the Dominoes topic. So the producer for the West Delhi will be different. The producer for the South Delhi will be different, but they all are referring the messages to one particular topic called Dominoes. And since you are connected or you are registered to the Dominoes topic, you are getting the messages from multiple producers. So that is what topic is. So 4 parts which we have talked about, 4 terms which we have talked about: producer, message, producer and consumer, messages, and topics. Another thing, where the major part, where does these messages get saved? Now that comes the part, and that is what we call it as the Kafka servers. Kafka servers can be of course, they are distributed systems. If you are working with Hadoop clusters, so where Hadoop saves the same, the data, how it saves on the nodes, same way on the same data nodes, which we call it as data nodes, where Hadoop saves these data. The Kafka servers are also the same one, making use of the same data nodes, and they retain the messages over there. But what are the services? Again, services means daemons. What are the services which are making, handling all these topics and all these messages and all that stuff? So Kafka servers, which we said, are a bunch of multiple nodes. So there will be one node, another node of the same capacity, you can say, and they all are saving the data which is being produced by the producers. And they retain this also on the disk. But who is monitoring the topics and all these stuff? The daemon, the service which does that, is called as the broker daemon. So broker daemons are the services which are running on every single individual machine, where the data is being stored. They are monitoring these messages, the topics and everything, and consumer who wants to get that message connects to the broker daemon, gets the data, and so basically, literal ways, producer produces, broker is the interconnection between the producer and the consumer receives the messages under that particular topic where it want to consume the data from, which is present on one of the broker daemons. So this is a very rough sketch of what a producer of basically the Kafka architecture. To conclude it, I would not to conclude it, just to give you this is a high level architecture of it. So this is the Kafka cluster where the broker daemons will be. So this is one topic called login failure. This is one topic called login failure again, and this is one topic called call placed. So under the same topic called login failure, 2 devices are producing the data. And the 3 consumers, consumer 1, consumer 2, consumer 3, they are using that topic called login failure. So they are getting all the messages under that topic. 2 consumers are getting the data from only one producer, that is call placed and call placed. So this is one of the rough sketch of an understanding of how Kafka works. You can have Flume as one of the producer where you're getting the data from, and you can store the data as per in the HDFS, or the consumer can be anything, or you can have a producer can be anything and the consumer can be a Flume architecture. So that is what mix and match happens in the industry. Like people are making combinations of it and making use of it, but this was a basic understanding of what a Kafka architecture is. Coming on to the use cases of Kafka, Kafka is used for a variety of use cases such as a log aggregation, because you need to collect a lot of logs which are working in the industries. Messaging, that is the vital important main use of it. The subscriber messaging system services which you get on the messages which you get are basically Kafka services. Website activity tracking, stream processing, event sourcing. So something which is related to event types of data, that is where your Kafka is built for. Now, there are a lot of things, messages. Yes, one more thing which was very important to talk about. Messages in Kafka are variable size byte arrays. And you can use any of the format, JSON, Avro, freeform text, any of these formats can be made use of. There is no explicit limit on the message size. So you can have from 1 KB to 1 MB of per message, means one event can be of this size, KB to 1 MB. Also, more thing, that it retains all the messages for a definite period of time. You can alter it if you're administrator. You can specify what is the retention period you want to take for. Sorry. It can be for reasonably for 1 year or longer, or default is for 1 week, I guess. Yeah, 1 week is there. Generally, people who have a lot of data which is to be kept, so they don't keep it for a week. Also, they keep it for 3 to 4 days, and they make use of it and retain it afterwards. So Kafka will retain the messages regardless of whether they have been read or not. So that is what the messages criteria is to retain the messages in Kafka systems. There is no explicit limit on the number of topics also. A topic can be created explicitly or simply by publishing to the topic. Cloudera recommends, okay, this is something which is Cloudera specific. Now we will be doing a practical example of this. The machine which I'm making use of is Cloudera's version, which is the freely available version. Sorry. The freely available version of Kafka, of Cloudera's Hadoop. You can go onto the Cloudera site and get the free version of it. If you are already working on it, then also fine. You can install the Apache Kafka over here. It requires Scala. My system already had Scala installed. You can get the tar file, unzip it, and work normally like I'm working in this particular system. So the first thing first which we're going to do is we are going to create a topic. So Kafka -topics. These are command line instructions. Moreover, yes, one more thing just prior to this before we go ahead. The Kafka producers and consumers are built up by it's built up in the Java language. Like you get proper APIs we have to build up for producer and consumers. Of course, we will not be able to do it in this particular session, but if you go for a classroom training, of course, we're going to understand how the producers are built up and consumers are built up. Also, one more thing is that it is quite impossible that you might get a readily available producer and consumer according to what your needs are in the organization. So you always have to build up. But the one demo which I'm making use of, or I'm showing you over here, is where we we're making use of the console to make use of the consumer and producer. So first thing first, we are going to create a topic. Kafka topics, this is the main command. And whenever we write subcommand, means double hyphens. This is one of the, you can say, syntax whenever you're writing a Hadoop related commands, or these related, even in Linux sometimes, whenever you're writing subcommands, you use double hyphens. So create is the name of the subcommand. And this is local host in the sense where my services are installed, and 2181 is the default one for this particular system. You can also try for 21810 if it does not work, because some systems make use of 21810 also. So yes, another one is replication factor. Now this was something I generally tell it over there itself, but I wanted to tell here. Replication factor retains the part where just yeah, replication factor represents that how this topic or this particular topic should be replicated in multiple machines. How many times? The replication factor describes or keeps in mind the fault tolerance. In the sense, if you have multiple machines and one of the machine fails, so do we have a backup of the topics which are available on that particular machine? So by default, if you're using a fully distributed cluster, you make use of the replication factor to be 3, which is in the Hadoop ecosystem as well. In any of the multiple distributed systems, you keep the replication factor to be 3. But since we are making use of a pseudo-node cluster, we are taking the replication factor to be 1. Partition. Now, what is partition? Since your messages or your topics can be increased up to a huge size, because carrying messages of 1 MB, and let's say you're getting thousands of messages in 5 minutes or something like that, so it becomes very difficult to retain all of them on one single machine. So by default, whenever you're making, or this is something where the admin part comes up, so whenever you're trying to run the messages or you're creating the topics, there itself you specify, taking an estimation of mathematics and calculation, how many messages you are getting in a minute or something like that, that how many partitions of that particular topic should be done. Each partition is retained on one of the node. So let's say if I have 10 partitions, then that means that topic, let's say Domino's has 10 partitions. So all these 10 partitions will be on different 10 nodes. But also mind it, they cannot be they cannot be partitioned afterwards if they are already partitioned onto the systems. So one partition, one node. Since we are using a pseudo node cluster, that is one machine where all the services are there. So I'm making use of only one partition. And let's say I give the name of the topic as shopping. Okay, so let's say if I've created, okay, it gave me, oh yes, I have missed on to one of the zookeeper. Yeah, so now one more thing which I skipped up over here was zookeeper. Now what is zookeeper with the services which is running on 2181? Zookeeper is one of the service which is there. Okay. Zookeeper is one of the service which runs is basically to monitor all the broker daemons, the producer, the consumer, and all that. Zookeeper is also working as a service. It's basically a service or a daemon which is running on 2181 port number. Now this service is not a part of Kafka. It is a part of the Hadoop cluster. But also, since it's a monitoring one, so people, I mean the Kafka clusters make use of Zookeeper also. Now, what is the use of it? Let's say if I have 3 systems and one of the system fails. So the majority is the other 2 are still remaining. So the work will not be hampered. But out of the 3, 2 are remaining. 2 of them crashes up. So I have just only 1 left. But the majority says that 2 of them have been crashed, so the system won't work. So Zookeeper gives you a liability of working on majority basis. So Zookeeper services are basically installed in a odd numbers of 3, 5, and 7. so that we can majority wise we can come to forward that whether the system should be working now or should not be working. So Zookeeper is one of the important aspects over here. So we are creating a topic called shopping over here. I'll just press an enter. So it has created the topic called shopping. Now to display the topics, so I will just write over here Kafka hyphen topics. If you guys need the commands over here, first of all, the session will be recorded. If you guys require that, you can ask on the DevLabs, you can get that, and these commands will also be available over there. These commands are also available on the Apache Kafka site for a demo introduction about Kafka. List, and then again we will write the Zookeeper command, Zookeeper on localhost 2181. So I made another topic called weblogs, which was prior to it, and shopping is the one which we currently made. Now is the main task. We have created a topic onto the broker daemons. Now we have to create a producer and a consumer. So let's say I call this terminal as, set the title as producer. So I'm calling this terminal as the producer. Okay. I have already, yep. So I have, sorry for the bad throat. It's the weather which is ruining this. Topic is shopping. All right. I have made a Kafka console producer. So it's a console producer in the sense, whatever I will be writing on the console, that will be acting as a producer to it. Broker daemons are present on 9092. So I'm using only one of the broker daemons. You can make use, the other broker daemons are, I guess, 9093, 9094. Yeah, so these are some of the broker daemons by default port numbers of them. You can check for that on the Apache Kafka site as well. So these are the broker lists on which the topic will be produced, and the topic name is shopping. And we just press an enter. So now this means that it is waiting for data to be written on, to be produced. We'll take another terminal, and that terminal will be called as the consumer. Let's call this terminal as consumer. And okay, so let's say shopping. Okay, so this is the Kafka console consumer, which is working, which is linking to the Zookeeper 2181, and it is also linking that which topic it wants the data from. And the subcommand again refers to from beginning, in the sense whatever may be, I have produced data already, and the consumer ran afterwards. So whatever the data had been produced earlier by the producer, I want to get that data from the beginning, from the very beginning. So we'll start off. The consumer is now waiting for the producer to get the data. So let us keep both of them side by side. And oops, sorry. All right. So if I write over there, close, let's say. So I'm getting the message over here as on the consumer, because since they both of them are console producers and consumers, so I'll be getting the messages, subscriber messaging systems like this. You can have multiple consumers if we're working on different nodes. You can have multiple broker daemons and so on. But this was just to check whether the producer and the consumers are working. The services, the same services you can provide it onto the cluster also. Of course, you're not going to make use of it on like according to what you're organizing. Not one by one, we will be pressing the events. We will be passing streaming data. So for that, you have to create an API, producer API and consumer API. And for making of that, you need to have a good Java orientation language. And that is something which we will do into the classroom sessions. If you want to, so this was a very basic understanding architecture, what Kafka does, why it was created. Keeping in mind the command concentration of, wait, where is it? Yeah. Now it's 4:52 already. So I'll keep 10 minutes for any of the questions if you want to ask, high level questions or anything The courses available are on DevLabs. I'll open up that site as well. You can go on to devlabsalliance.com if you want to enroll for any of the classes given here. We will be making use of in the classroom sessions. We will be making how we have consumer groups, how we can make producer API, how we can have consumer APIs on Java.
Gurleen, Sachin this side, I have one question. So can you please help us to understand what is the major difference between messaging queue and the Kafka?
Messaging tube and Kafka.
Messaging queue and Kafka, yeah.
MQ, you are saying?
Yeah, MQ, yeah.
Okay, basically I've not worked with MQ, but there was one of the major difference which MQs referred. I guess it was retaining policy. And also it worked on queuing. I mean, it is mostly like queuing system, but Kafka does not work the same way. Like it does not queue up the messages in that format, what RabbitMQ does. But I'm not sure of this. The reason is because I've not worked with RabbitMQ. I have not much knowledge on that one. But I'll get back to you on this one. You can mail up your question also if you require, and I'll get back to you on this same.
Sure, yeah. Thank you.
Okay, thank you. Anything else if you guys want to ask for about the other courses as well? Like I personally take the big data Hadoop courses, data science courses as well. If you guys want to ask about anything related to this, you can ask also in the chat box or maybe.
Hello, Nikhil, this side. Can you explain, can you show us how the Zookeeper is working? Like you mentioned that it is going to manage all the producer consumers. So is it possible for you to show us a Zookeeper? How does it
Zookeeper
maintains?
is basically a service which is running in the background. It's like a daemon. Okay, so yeah, so it's basically if you do, where is the terminal actually? Oh, it's not there. Okay, it's not showing over here, but yeah, so Zookeeper, how it works, if I tell you about, is, let me tell you an architecture way of it. So let's say I have 3 systems which are working, like they are saving the, okay, do you know anything about quorum nodes? Quorum, Quoram, quorum nodes?
No.
Okay. Quorum nodes are basically, right, quorum nodes or these journal nodes, which we call them, they are something which works in the odd numbers, in the sense, yeah. So let's say this is one of the Zookeeper, which is running. Zookeeper, I'm just reading it 1. The second Zookeeper service. So what do they do is they are installed on all these separate machines, that is the distributed processing systems. And let's say one of the Zookeeper or one of the machine fails up, or one of the Zookeeper turns off. So what how it monitors in the sense is that it is saying whether the name node, the data node, I'm sorry, talking about the Hadoop architecture I'm talking about, the data nodes, the master nodes, the slave nodes, whether they are working correctly or not. They are monitoring all these services, slave daemons, master daemons, secondary daemons, or we call it as standby daemons, all these services. Now, what it says is that if you are installing them in an odd number, if this particular goes down, so we have a majority of the other 2 Zookeepers working correctly fine. But if the third one also goes down, or let's say 2 of them goes down, only 1 of them is working, so it halts the system to produce further messages or to retain any other messages. Reason being, because the majority says that the 2 Zookeepers are down, the 2 services are down, And since from the majority, only one of them is working, it is taking a risk. It is a risk-taking manner. So in this particular order, considering as the administration part of it, Zookeeper only does the monitoring of it when you are working on a fully distributed cluster.
Okay, thank you.